Hello Year 11, this is the Combined Science Physics Higher Paper 1 Masterclass. Make sure you're in the right room, make sure you're looking at the right video. This has been made with the advanced information in mind, so if you're looking at the wrong video or you're in the wrong room, then it's not going to be as beneficial. Okay, now the way this is going to work, we're going to have different colour slides and we're going to have different activities to go with them. So when it's red like this means that we are listening, we are reading, and generally speaking, it's going to be lots of finding the mistakes in exam question answers. Okay, we're going to focus on common mistakes and common misconceptions that students do in their exams. Okay, so hopefully you don't make those mistakes. So when it's red, we're listening and we're reading, but when it's green, that's when we're reflecting, that's when we're writing, that's when we're fixing the mistakes. That's when we're doing. So the red is when we're listening, the green is when we're doing. Okay, now this is the advanced information that you should have all seen before. Okay, so coming up in your exam, the focus is there's going to be a big section on energy, so energy changes and systems. We've got energy transfers, we've got changes of state in the particle model, we've got the particle model and pressure, we've got atoms and isotopes, and atoms and nuclear radiation. Those are the areas of focus. Now other sections can come up, but these are the sections that are focused in the exam. What's not going to be examined is series and parallel circuits, domestic uses and safety, and internal energy transfers. Now we know that two required practicals will be assessed in some form. We don't know how many marks they will be given for each of the required practicals. So one is on finding the specific heat capacity of materials, the other is on the IV characteristics of resistors, filament lamps, diodes, and resistors at constant temperature. But we don't know the ratio of the marks. We don't know if one's going to have 1 or 2 marks as an answer, or it's going to have 10 or 20 marks even. Okay, we don't know the number of marks, but we know they will be assessed in some way. Okay, so your first job, we've got this question. This is a difficult question, and this has been answered incorrectly. So this is a possible 6 marks, and the student, if they answer a question like this, gets none. Okay, now this is tricky because a lot of what they've said is true, but they're just not putting across their understanding in a way that gets them marks. Okay, so I want you to pause the video here and I want you to try and fix the mistakes. So pause the video now. Okay, so hopefully moving on. Now, a big issue with this, so first, using wood, it is a biofuel, but it is a renewable biofuel. Okay, you can burn the wood, you transfer energy, and that wood is gone, but you can plant the tree again. Okay, so it is renewable and it's a biofuel. Saying it's eco-friendly, while that might be true, you need to be specific in why you think it's eco-friendly. Just saying eco-friendly is not good enough to get marks on a physics exam. You need to say why. Giving out pollution again, you need to be specific. What type of pollution? The second part, part C, this is tricky. So it just says, describe the change to the store of energy of the wood, pipe and water as the water is heated. When the exam asks for a change, it's looking for something that goes up, something that goes down, or something that stays the same. So even though when they've said the chemical energy was transferred to heat, while that's being true, chemical energy is transferred to heat, that's not talking about the change. So to get the marks, we need to have a renewable biofuel. We need to say something like it causes deforestation. So a specific reason why it might be eco-friendly. Gives out air pollution like CO2 or soot. Okay, but that last part, whenever you see change, think that you have to write either it's increasing, it's going to stay the same, or it's going down. So to get the marks, they have to say that the chemical store decreases. To get the marks, they have to say the thermal store increases. Not just that there's a change to it, but what that change is. Describe the change to the store. Okay, so be really careful when you see the word change in your paper. Next, we've got a difficult question, a different calculation on specific heat capacity. We've got an air in a balloon, it's got a mass, it's quite a small mass, 0.0032 kilograms. We've got the temperature of the air in the balloon decreasing by 215 degrees. There's a change in thermal energy of the air in the balloon of 860 joules. And we need to use the correct equation on the equation sheet, which is this one, okay, to calculate the specific heat capacity of air. You need to find the mistake and you need to fix it. Pause the video now. Okay, so this is a really common mistake that lots of students do. they substitute after they've rearranged. Okay, now if you rearrange correctly, that can be okay, but if you've got any doubts about your rearranging, you're going to lose marks. So here, because they rearranged this equation incorrectly, they get 0, absolutely no marks. Whereas if you just first substitute correctly, you're bound to get the single mark from the beginning. Okay, so here I've got the equation written correctly, and then I'm looking at putting the right number in the right spot. So if I've got a mass of 0.0032, I could circle that or underline it, and I know that that goes into my mass. I know my 215 temperature change goes into the change in temperature. I know my 860 goes into the change in energy. Okay, leaving behind the specific capacity, the thing that I don't know, the thing that I'm trying to find out. Okay, so once I've substituted in, then I can make my life a little bit easier by simplifying it, by timesing 215 by the 0.0032. Okay, I simplify that a little bit to make the rearranging a little bit easier. Okay, so I substitute, I might make it easier, I might simplify it, then I rearrange, then I got the answer, then I put it in my answer line. Okay, so make sure you substitute first. Okay, substitute first is a really important thing to do. Okay, next, your specific capacity practical. Okay, so I've blocked out a number of different pieces of equipment. I'd like you to write down what they are and what they're used for in the experiment. Okay, you could use a joule meter instead of these 3 things. Okay, a joule meter directly measures energy. Okay, but it's not as accurate as using these 2 pieces of equipment. Okay, you could improve it by adding insulation. Where would you add the insulation? Okay, the next thing you need to be aware of is how you would calculate the change in specific heat capacity. What would you do to calculate the change in specific capacity? How do you rearrange this to get C? Okay, I've got a quick little method that you could have a little bit of a sketch through, and you can maybe think about how you could make it better. And I've got a little calculation that you need to try to find the energy transferred, okay, in 5 minutes if there's a current being drawn of 2 amps over 6 volt potential difference. Okay, so try and answer those questions there. Okay, so hopefully moving on, we've got a thermometer, measures temperature change. Now in your methods, whenever you're writing a method, be really specific in what the piece of equipment does. Don't just assume that the examiner knows it's for measuring temperature. Tell him. Okay, say the thermometer measures temperature. The voltmeter is to measure the potential difference. The ammeter is to measure the current. Combining these 2 things, I can calculate power, and if I have a stopwatch, I can calculate the time. This is what this bottom part is doing to calculate the energy transferred. Okay, here is my rearranged equation to calculate specific heat capacity, and here's my workings to find that energy. So we've got 2 amps of current with a 6 volt potential difference on for 5 minutes. We can get 3,600 joules. Be careful of the 5 minutes. Make sure we change that unit into seconds. At some point in your paper, it's incredibly likely that there will be a place where you have to change from minutes into seconds or hours into seconds. Okay, make sure you spot that and make sure you do that change. You'll get a mark for it. If you get to the end of your paper and you haven't had a change of unit like that, go back through and try and find it to try and get that mark. Okay, because it will be there somewhere. Our next required practical is on IV graphs. Okay, so I've got a circuit diagram. I've got 3 components that haven't been labelled properly. I need to try and label those. What does the graph look like from a filament bulb from a diode? What's the shape of those graphs? Okay, record the potential difference with the voltmeter and the current with the something. Okay, have a look through the method. What can go behind here? What's my detail for the results for the bulb? So the Ohm's law for a resistor, it obeys Ohm's law. I know that because the potential difference is directly proportional to the current. It's a straight line that goes through 0. Okay, the steeper the line on this graph means the resistance is lower. Okay, you get a larger current for a given amount of potential difference. What does it look like for a bulb? What does the bulb graph tell us? What does the diode graph tell us? pause the video and try and fill in that detail. Okay, moving on. We've got a cell. You could have a battery here or a power supply. We've got a variable resistor, an ammeter, whatever the test component is, so a resistor or a diode or a lamp, and the voltmeter. Okay, the cell is there to provide a potential difference. The ammeter is there to measure the current. The voltmeter is to measure the potential difference. And the variable resistor is to control the current, to control the potential difference across this component, so I can plot out these graphs. So I've got the ohmic conductor, a resistor, a straight line, goes through 0, is directly proportional. A filament bulb, okay, is not directly proportional. It is not a straight line. It goes through 0, but it is not a straight line. Okay. When you have a high current flowing through the bulb, the resistance increases. The resistance changes because it gets hot. Okay, so at a high potential difference, the bulb gets hot, heats up, and the resistance goes up. A diode is not directly proportional. It does not obey Ohm's law. It is not a straight line that goes through 0. Okay, it only lets current flow in one direction. Okay, when you've got a negative potential difference, the resistance is incredibly high. It doesn't let current flow. Okay, only with a positive potential difference above some threshold voltage will you get current flowing. Okay, so make sure we know those graphs. Practice sketching them. Next, we've got another calculation question that you need to find the mistake in. You need to find the mistake. So we've got a toaster. Okay, and the toaster's finished toasting. We've got a nice toast to eat. The toaster's moved upward by a spring at the end. There's a change in gravitational potential energy of 0.49 joules. The mass of the toast is 0.05 kilograms. The strength of gravity, the gravitational field strength, is 9.8 newtons per kilogram. Calculate the change in height of the toast. Okay, so make sure we substitute first. Okay, pause the video here and try and correct that question. Get the right answer. Fix the question. Pause. Okay, moving on. So this student didn't substitute correctly. Okay, so be careful when you're doing your substitution. I do think it's easier if we underline or put a box around our different values. So we can underline the 3 numbers that we're given. Okay, then, and you can do this in the exam, you can draw a line to the place in the equation. So the change in gravitational potential energy, that goes at the start over here. The mass goes down here. The strength of gravity goes here. Okay, so this student hasn't correctly substituted in. They haven't put the things in the right spot. So when they then go to the answer, it's wrong. Okay, so we need to be careful about how we substitute, okay, into our numbers. So this is our correct answer. We've got a substitution first, then we need to rearrange to find height. Okay, make sure you're careful in using your calculators. Put in the brackets. If you forget to use the brackets, not using your calculator correctly, you'll do 0.049 divided by 0.05. Okay, you'll get that sum, then you'll times it by 9.8 and get the wrong answer. You need to be careful about the order of your calculations. Think about your BIDMAS or BODMAS from maths. Okay, and our height is 0.1 meters, which is the correct answer. The next thing you need to be really careful of is using the right equation. Choosing the right equation on the equation sheet. So for this question, just highlighting or underlining the quantity, so gravitational potential energy, the mass, the gravitational field strength, and the height. To choose the right equation, I will go through my equation sheet until I find one that has those, in this case, 4 things. I'll discount kinetic energy, mass, and speed, the kinetic energy equation, because I don't have the right things. I'll do the same with the elastic potential energy. Okay, I will choose the equation that I've got the different parts for. Okay, go through the equation sheet step by step until you get to the right equation. Okay, be really careful. Use the equation sheet. We're given it. You're the only year that's going to get this. Next year's year 11s, those current year's 10s, they need to remember all these equations. Okay, so take advantage of the extra help you're getting. Use this sheet. Have it next to you whenever you see the word calculate on your question. Be ready to take those equations and use them. Okay, get those marks. Our next question is about making ice cream. So this is a diagram showing a bowl used for making ice cream. The walls of the bowl contain a liquid coolant. The liquid coolant's at minus 20 degrees. The bowl is cooled to minus 20 before the mixture is put into the bowl. So there's the mixture we're going to make the ice cream. The bowl causes the mixture to cool down and freeze. Okay, and we've got an inner metal surface and an outer plastic surface. The question that you need to do is you need to explain why the different thermal conductivities of metal and plastic are important in the design of the bowl. You need to find the mistake and you need to fix it. Pause the video here. Okay, moving on. Now the important part of this question is in the question itself. We need to be really careful in reading what the examiner wants us to do. So it says explain why the different thermal conductivities of the metal and plastic are important. If I talk about insulating properties, I'm not going to get the marks. I need to talk about how good it is at thermal conductivity. Okay, so saying metal is a poor insulator, not going to get anything. Saying plastic is a good insulator, it's not going to get anything. I need to say that a metal has a high thermal conductivity. A metal is a good conductor of heat. That increases the rate of energy transfer. Okay, plastic has a low thermal conductivity. That reduces the rate of energy transfer to the surroundings. Okay, you need to use what it says in the question. Really read the question and try and answer what it's asking, not some other question. So when it says explain why the different thermal conductivities of metal and plastic are important, you need to talk about the thermal conductivities. Okay, quote what it says in the question, use it. Next question is about pressure. There's a canister of air was tested to find out how the pressure changed when it was used by a diver. Air was allowed to escape from the canister. The pressure of the air in the canister was recorded every 5 minutes for 80 minutes. We need to use this graph to estimate the atmospheric pressure, and then divers can safely stay underwater until the pressure of the air is reduced to 25% of its original value. Determine the maximum time the diver can stay safely underwater. Use figure 2. It says use figure 2. It says use figure 2. Use figure 2. What happens to the volume of the air when it is released from the canister? You need to find the mistakes and you need to fix them. Pause the video here. Find the mistakes. Okay, so moving on. This question, okay, not all of it's been answered incorrectly. Okay, now I realise that using a screen or using a screen, a whiteboard up on the board, it might be difficult to get the numbers from the graph, but you need to be careful when you do that. So immediately I can see that the student hasn't used a straight line, a horizontal line when they're using this graph. So immediately that jumps out as a mistake. The first part is correct. Okay, that atmospheric pressure is 0.1 megapascals. That's where it levels off. That's where it's not decreasing anymore. So the gas won't be leaving the canister or going into the canister because it's an equilibrium. The pressure inside and outside the canister has matched. So the atmospheric pressure is 0.1. Okay. Now in this question, there's two mistakes. One, we haven't used a horizontal line. We haven't used a ruler on our graph. And two, we've been too quick in trying to get that first value. It's not 2.5. Okay, it doesn't start at the very top. It starts halfway between. So our true value, okay, is not 2.5 but 2.25. So here's the correct answer where we get all 5 of the marks. So we've got 2.25 times by 25 divided by 100, 25%, to get 0.56 megapascals. We go along from 0.56 onto our graph and down to 27 minutes. Now, if you're able to get anywhere from 24 minutes to 28 minutes to 29 minutes even, I would give you the benefit of the doubt in this situation because it would be difficult for you to use this graph. Okay, what happens to the volume of the air when it's released from the canister? The volume will increase. Okay, the pressure has reduced, so the volume will go up. Okay, the next thing we're doing, you need to spot why the student only gets 2 marks. Why do they only get 2 marks in answering this question? What have they done wrong? Okay, we've got a student doing chin-ups. lifting their body up 0.4 meters vertically upwards. The mass of the student is 65 kilograms. The student's able to do 12 chin-ups in 60 seconds. Pretty good. I need to calculate the power developed by the student. Okay, so what is the power of the student thinking about this change in height, this mass of 65 kilograms, and we've got a gravitational field strength of 10 newtons per kilogram. We need to use the right equation from the equation sheet, and we need to calculate that power. Why do they only get 2 marks? Find the mistake, fix it. Pause the video here. Okay, moving on. The student only got 2 marks, okay, because they didn't really use all the information in the question. Because it's a 3-mark question, okay, these 3 marks, we need to do something extra rather than just substitute in and get an answer out. Okay, it's a little bit of a harsh question really for 3 marks. I think it should be 4, but, okay, we didn't use this idea of 12 chin-ups. So we've got the correct energy transferred for a single chin-up, which is 260 joules, but he's done 12 of them, or the student's done 12 of these chin-ups, so we need to times that by 12 to get the total energy, which is 3,120 joules. Then to calculate the power, we do energy divided by time. 3,120 divided by 60 to give me 52 watts. Okay, so we need to be careful that we're using the information in the question. Okay, didn't read the question properly. Next, moving on, we've got why did the student only get 1 mark? Okay, we've got the energy transferred from water in the kettle to the surroundings in 2 hours is 46,200 joules. Calculate the average power output from the water in the kettle to the surroundings in those 2 hours. Use the correct equation from the physics equation sheet. Okay, why did they only get 1 mark? Find the mistake and fix it. Pause the video here. Okay, so this question, they didn't finish converting the units. Okay, they've got this 2 hours. Okay, they started to change it into minutes, so they got minutes, but they didn't change it into seconds. Okay, so 120, 2 times 60, but we need to times it by 60 again to change that 2 hours into seconds. So we do that 46,200 divided by 7,200 to get 6.42 watts. So be careful in those conversions. Now, as I said before, there'll be at least one place in your exam where you've got to change units. At least one. I think there'll be more than one. Because you're given all these equations, I think the examiners are going to be asking you more about your math skills that you don't get help with. So I think there'll be more cases where you've got to change units, or you need to go from kilometers to meters, something like that. I think there will be a number of occasions in your paper where it's going to be asking you to do that. So find them, check them. In each question, make sure that you don't need to convert the units. Okay? The next question, this is a very difficult question. The initial temperature of the mixture was 20 degrees. The mixture froze at 1.5 degrees Celsius. A total of 165 kilojoules of internal energy was transferred from the mixture to cool and freeze it. The specific capacity of the mixture is 3,500 joules per kilogram degree Celsius. The specific latent heat of fusion of the mixture is 255,000 joules per kilogram. Calculate the mass of the mixture. Give your answer to 2 significant figures. This is a difficult question, but there's a couple of things that you need to go into it thinking. First, it's 6 marks. If it's a 6-mark calculation question, okay, you need to use 2 equations. There'll be 2 equations you need to use. Now, there's clues in the question what equations you need to use. This one is relatively straightforward because you're given a specific heat capacity and you're given a latent heat capacity. So those are the 2 equations you're going to have to use to answer this question. Okay? Sometimes, especially when it's 6 marks instead of 5, you'll be asked to do something extra, like giving your answer to 2 significant figures. Now, these questions are hard. These are difficult questions. But there are lots of places where you can get marks. So don't leave it blank if you're really struggling with it. If you think, oh, this is difficult, don't just leave it blank. Try and use at least one of the correct equations to get some calculation marks. Okay? You can get 3, 4, 5 marks with this and still get the wrong answer. Okay? So try. Okay? So for instance, for this one, just getting the change in temperature would get you a mark. So don't leave them blank. Give them a go. Okay? So let's try, to the best of your ability, try and get that mass now. So pause the video here. Okay, so moving on. This one, so that energy change is for both the change in temperature and the change in state. So those are our two equations we need. The change in energy due to a change in temperature and the change due to a change of state. So the total energy would be those two added together. Okay, mc delta theta plus ml, where m is the thing I'm trying to find, that mass. Now I know the total energy. Okay, I'm told that in the question. The total energy is 165 kilojoules. Change that to joules times by 1,000. It'll get you a mark if you don't do anything else. Okay, and that equals, and then I substitute in my specific heat capacity and my change in temperature, and I add that to the energy needed to change the state. Okay, 255,000 joules per kilogram. Okay, then I can simplify this. I can simplify it again, and then I can rearrange to get a mass of 0.499621 kilograms, and to two significant figures, it's 0.59. Okay, now there are a number of places where you can get marks without getting the final answer. So even if you get lots of it wrong, you can still get marks. You can get a mark. You can get a mark for getting the correct conversion of the energy. You can get a mark for rounding to two significant figures. Okay, you can get lots of different marks in this question. So you need to be really careful and really careful. Give the question a go. Okay, give the question a go. Next, we've got another multi-equation question. We've got a question about a kettle. So a kettle is 2.6 kilowatts, not just watts, 2.6 kilowatts. And the kettle took 120 seconds to heat 0.8 kilograms of water from 18 to 100 degrees Celsius. Calculate the specific heat capacity of water using this information. Give your answer to two significant figures. 6 marks means two equations. Okay. Now this one's a little bit trickier than the last one to figure out the equations because you've got lots of different power equations. Okay. But you need to be careful. So first, you need to know specific capacity. I'm going to have to use the specific capacity equation. Okay. For power, I'm given a power and I'm given a time. So choose the correct power equation. Okay. Try and find out the answer to two significant figures. Pause the video here. Okay, so using that equation, energy equals power multiplied by time. So the total energy is the power rating of the kettle. Okay, the power rating, which is 2.6 kilowatts or 2,600 watts times by 1,000 times by the time it was on, 120 seconds, to give that total energy. Okay, 312,000 joules. Then I can put that energy into my specific heat capacity equation, okay, to then rearrange to find specific heat capacity. Now again, this is 6 marks. There are lots of places where you can get those marks. Lots of places, okay. If you don't have anything else, there's a good chance you'll get a mark for a temperature change. Okay, if you don't have anything else, going from 4,765 to 4,800 will get you a mark. Okay, if you were to just substitute, get the total energy, and then substitute into the specific capacity equation, you're getting 3 marks for that work. Okay, so even if you're not getting to the final answer, you're getting a lot of the marks in the question. Okay, now these questions are hard. You'd expect them to be at the back of the paper. Okay, but get as many marks from them as you can. Okay, we're going to do one more. This next one is about water vapor condensing on a mirror. Okay, so we've got water vapor is a gas. Gas changes state when they cool. They've lost internal energy. The internal energy goes down and they can change state. Figure 8 shows condensation on a cold bathroom mirror. And we've got the question. A volume of 2.5 times 10 to the minus 5 meters cubed of condensation forms in the mirror. The density of water is 1,000 kilograms per meter cubed. The specific latent heat of vaporization of water is 2.26 times 10 to the 6 joules per kilogram. Calculate the energy released when the condensation forms. Okay, it's 5 marks. That means 2 equations. We haven't got the 6th mark, which means we need to do something extra. We're just using 2 equations. We're rearranging. We're getting a mark out. Okay, now how do I know it's the density equation and the latent heat equation? It's because I'm given this idea of density and volume. Those 2 things together can get me a mass. Okay, the specific latent heat of vaporization, that means I have to use the latent heat formula. And the latent heat formula, E equals ml. It's got my mass. It's got the latent heat of vaporization constant. And the energy is the thing that I'm looking for. So those are the 2 equations I need to use. Okay, so let's try and answer that question as quick as we can. Pause the video now. Okay, moving on. So we've got the first job. We need to calculate that mass using the density equation. So we've got 1,000, which is my density, equals mass divided by, which is my density. 1,000 equals the mass divided by 2.5 times 10 to the minus 5, the volume. Density is mass divided by volume. So the mass equals 2.5 times 10 to the minus 5 times by 1,000 to give me 0.025 kilograms. So there's my mass. That's 3 marks. Okay, it's more than half the marks in the questions. Just do that first part. Then I can substitute it into my energy equals mass times my latent heat of fusion. I can times those 2 things together to get 56,500 joules, which is my answer. Okay, if you just write E equals ml, you're not going to get the marks. If you just write down the equations, you're not going to get enough. You need to substitute to get the marks. Okay, now that's the end of this little masterclass. I hope it was useful. Please tell your teachers what parts you found useful or what parts you didn't find useful, so we can change for the next series for our paper 2. Now I know you're going to do your best in your paper. I know you're going to do your best in the exam. Try your hardest. Okay, you're going to absolutely smash it. Well done for working so hard. Okay, best of luck.